I feel like I was like, Nelly, do surprise me. The last time someone introduced me and surprised me, they said I liked clogs, which was Lars, which is a classic thing from him. But thank you. I did not expect to shout out to the podcast, but yeah, do a podcast. I don't know. It was lockdown times. I was bored. But thank you for coming in and picking this session to come listen to. I know there's a lot of other stuff happening at the same time. So I'm very flattered. I'll start with that. Thank you so much for joining in. And I hope you have had a pretty great start to the day. But let's dive in. I know lunch is right after, so I'm going to try and keep it on time. No one wants to be sitting here hungry. So we're going to dive in and talk a little bit about myself, because we haven't already done that enough. But my name's Akanksha, and I am a data and AI consultant based out in Melbourne. I've been consulting for the last, I think, over 5 years-ish, somewhere around there. And yeah, I'm a Microsoft AI MVP as well. So in and around that whole data AI sphere of things, I enjoy talking about them. I do these kind of things where I've learned a few things. I'm like, hey, found this here. Other people should know about it too. So that's kind of why I'm here. So digging into a little bit more of the why. Let's move on to the next slide. Why this talk? Why are we talking about these considerations for MLOps? In the last year or two, we've had a bunch of clients that come through and they're like, hey, we did the thing. We built a model. I'm like, amazing, keep going, tell me more. We just don't know what to do with it. It's usually the conversation, right? Which is fair. I mean, it takes a lot of work to get to a stage of building a model. This conversation has died down a little bit in the last 6 odd months, I'd say, maybe 3 months. Because I think we just talked about LLMs. They've taken over the conversation. But at the end of the day, most businesses have data, and ML models are usually the ones that will solve the bare minimum ones. So we will come back to this. We're going to come back and talk about the basic ML stuff a little bit for the next 20 odd minutes. So yeah, you built a model. I'm very, very proud of you because you've been through so much to get here. So we're going to do a little bit of a backstory, and we will get to the point of MLOps, I promise. But let's just set the scene of what's taken to get here. You have a problem. The fact that you've identified a problem that can be solved by ML, in and of itself, a big achievement. But from there, you've gone and found the data, sourced it, cleaned it up, put it in the right place, made it available for it to be used in the right environment, found money to be able to sponsor this as a project, and then started building the model. Like, it's not a joke. 90% of a data engineer's or data scientist's job is just getting data ready to be able to do stuff. And then you've gone through, built the model, and you're like, oh my God, it works. And they're like, it's not that good. Keep working on it. And you keep iterating. It's taken so much effort, but we've made it. And your workspace at this stage, when you've done so many iterations of data sets and featurizations and experiments, it might be really clean. You might be one of those people that has everything labeled perfectly and variables are named right, and you don't have untitled file number 18 as an IPython notebook. I'm not one of those. Mine usually looks a bit more like this. This is a physical one, equivalently available in your digital environment, I'm sure. I have been crucified by a maths degree. I can't name anything not being X, Y, Zs and ABCs. It is impossible for me, but that's usually kind of where you end up, and that's not a great starting place. It is messy. It's hard to explain what's happening to other people. And the other thing is, you tend to end up in this scenario usually because you're working alone. You're usually sitting there in your own little environment, because if you've found a problem you want to solve using ML, people don't really believe enough because you can't promise an outcome until you build an outcome. So when they don't believe enough, they tell you to go do a POC. They're like, go build something, come back if you have a result, and we'll look into it again. So you usually built it all alone or in a single environment, and it's then a case of, great, I got here. Where do I go? How do I make this a thing? What do I do with this? So where do we go next? And that's usually where businesses come in, and they're like, can someone come help? Can someone validate this makes sense? We think it does, but help. So usually our data scientists kind of sitting there having gone through hell, and they're like, yeah, works on my machine. I'm done, right? Because they don't really care about the rest of it. They've done their part. They've built a model. But we don't want to leave them there. We want to be going forward and actually scaling this out to the business that has the problem that they started with. So this is kind of where we're all stuck at. It's like, we want to deploy it, but I'm a little bit too afraid to ask. So if this is kind of the scenario we're going to be talking about, usually smaller teams where there's maybe a couple of people in the data science team, or there's a really small team trying to actually push their model to productionization, these are the considerations they should be taking in place. If there's a really big team and you've got like 20 odd machine learning engineers in your enterprise already, you're probably doing all this stuff. It's a good reminder to come back to basics. But most businesses that we talk to and I've seen come across have the same kind of questions and considerations they need to look at. So that's what we'll be talking about today. So from here onwards is what do we actually need to be looking at? So this is where MLOps comes in. You've built the model and you need to operationalize it. Fancy, fancy word, but essentially it's just, hey, let's put some kind of governance around what we're going to do and make it good and easy and reliable. So the main kind of key aspects of this that I look at is like, hey, can we make the model fast to be used and to be built and to be deployed? All the things just fast, because we live in this world where we just want everything immediately. It needs to be reliable. So over time, when the business is looking for those solutions that they're asking for to that problem they have, they need to know that the answers they're getting back are actually accurate or that they are somewhat reliable. And as time goes on, there's new data coming in. We need to make sure that that data is being reflected in those answers. So a year later, we might have another pandemic or another kind of global thing that takes over the world. The results and things need to be answering. The model needs to be replicating the reality of what's happening. And then scalable. Over time, there's going to be more and more data coming into the products at any premise. Data is being generated every second of the day. All of that needs to actually then be stored and utilized into the model and completely trained again and again over time. So that's what MLOps makes our lives easier, by essentially making sure those three aspects are being focused on. Is it DevOps? Is there any software engineer variety in here? Oh, phew, okay, right. For a second I was like, none? Oh my gosh. It kind of is, it's based on the same principles. This is kind of the usual DevOps-y circle of life we see thing. You have a thing you want to build, you plan it, you build the code, test a little bit of it, release it, it gets pushed into up production, and you monitor it. If something breaks or there's a bug, you start the cycle again. Essentially, the exact same thing happens in the MLOps side of the world. It's just a little bit changed to kind of fit the process of machine learning. Because there's a little bit differences in terms of, hey, we might have different data and things might change and the model might change. So it just reflects the different process. So what is the process? Let's look at it. So we've got the data development. So we talked about all this data in the big wide world. It needs to be sitting, it needs to be cleaned, it needs to be processed, and we need to make sure when there's new data coming in, it reflects the end world, right? Like it reflects exactly what the next stage expects to see. So it's all cleaned and prepped. The model development, our data scientist is actually building the model. They need to be able to make sure that the results coming through, the model is working properly. From there, once we've built our model, it gets produced, it gets productionized into deployment. And once it's all there, our business is happy. They have a use case and they can actually access it. So that's usually a very quick rundown of what a process looks like for machine learning problems. And within that, we've got a fabulous little team. So there's a bunch of people that do this. Not a single person can do every single thing. If you are a single person doing all of these things, I am so sorry. Please come talk to me afterwards. We can have a sympathetic therapy session. But there's a data engineer who's managing that first part, right? The data pipelines, who's managing making sure data's okay, it's validated, there's nothing going wrong with it. And the data scientist who then uses that data, which has been gone through a load of processing layers, and they just kind of look at the final layer and go from there. They take it away, they add all the smarts into it, they add all the models and stuff, and then from there, we've got the ML engineer who knits it all back up into an architecture that actually can be reliable and can be scalable over time. So this is kind of where they fit into our process. They do overlap quite a lot. They need to talk to each other pretty well. And this is where the considerations start. So this is kind of usually the different aspects that we're going to be looking at. And within that, there's a lot of considerations. So the point here is, this is the setup considerations now. You've built a model. We've gotten to a stage where we're like, okay, we've got data and it works, and we've got a model and it works. How do we productionize it? We're going to start building things. So these are the things we need to look at and consider as we start going into that process. So the team structure is going to be the first one, where who is in your team? If it's a one-man team, again, I'm very, very sorry, but again, these are the things you need to know. So if it's only going to be a solo team effort, the things you start looking at is going to be a lot harder to do, so maybe you kind of cut down on different aspects of it. If it's going to be a bigger team, but you know you're quite fragmented and siloed and you don't talk to each other enough, again, it's going to have an impact on how well these things are going to go collaboratively. So in terms of how a workspace is set up, it could be per team. If you've got multiple different teams working in the scenario, hey, your team is doing all of this, you have same level of access within the workspace that you're working on, off you go. Or it might be the case that it's per project. You've got multiple different ML projects happening, and you do want to make sure that the artifacts don't start getting confused. It happens so quickly that it's like, hey, this data is actually for this specific thing, and this one's here, and you're now talking to the individual data sets and they're completely wrong, or you've changed the data at a source level somewhere else. That can happen really easily, so it could be better to set it up per project. Or you can have a single workspace where you're just in charge of everything. That's probably an ideal scenario for if it's a solo team kind of effort doing it. It turns into chaos very, very quickly. Just be very, very careful about it. If you are someone who's very organized, great, this might be the perfect solution for you. I would die in that scenario immediately. It just would not last for me. But again, this is going to be a very consultant-heavy talk. It depends. It's going to depend a lot. And it'll keep depending because, hey, does your team communicate really well? Okay, great. Then we can have a workspace per project, because then each individual member knows what they have access to or what they're working on at a different time. If they don't do that necessarily well, maybe it's per team they want to be doing it, because it's, hey, everyone has the same level of access, so that I don't need to wait for you to come back to me with what you do and haven't done yet. So have a chat to your team. It's always really fun to be like, hey, how do we work? What's the best way of doing this? Another thing is environment. So we've done a lot of this stuff where like, okay, we've built it, we're going to productionize it, and kind of the main key aspects of environments that come into play are the usual ones we've seen, dev, test, prod. They do exist for this kind of stuff as well. Picking which is the best way of doing this, again, comes back down to, you guessed it, depends on your environment and your teams. And the only reason for that is you can have an environment like this. I've just used Azure as an example of what resources you might have within them. It can apply to any different cloud services. But you might just have a dev environment where you build everything, right? This is where you do all your creations, your testing, experiments, everything. You're like, okay, and this titled XYZ final prod model, it might be your registered model, and you're like, that's the one you push to your test, which to that environment, you can invite a few selected users to test out your model, and then it goes to prod. So it's not replicated anywhere else. That's a single environment development. You could have a multiple environment development where the exact same thing exists 3 versions, so you keep everything really separate. As you can see, there's going to be a lot more kind of cost associated to this immediately, because there's 3 variations of resources running, but also management of those, right? If you don't have a big management team behind you, this is going to go up in flames very quickly, because you might not get access. Everyone's kind of going in through it. If everyone has access, who's messing around with it? Who actually is controlling where things are going? And you probably don't want to give access to your storage and prod to every single person, because they're just going to blow up your data set. And the clean data set you worked so hard to get, they get destroyed in minutes very easily. So this is one option, again, depending on kind of how your teams are built and what your current environment setups are. If this is the way your business and your team operates in and of itself, it's a good fit because you know how to deal with that. But if you've never dealt with this kind of amount of resourcing and stuff, please don't do it. It's going to explode very quickly. And a kind of halfway between the two is a limited access kind of multi-environment, where you might just have a dev and a prod environment. And the dev might have kind of portions of the data. You might just take a sample size to build and experiment and test on. So it can save on costs and all that kind of aspect of, it's really important. The cloud footprint is a big thing to consider when you're building any machine learning aspect. And once you're ready to go, you push it up to prod and it kind of goes from there forward. And this way you can also kind of limit who has access to what things and you're not blowing things up. So all that kind of plays very big parts. And usually if you're just beginning into the MLOps side of the world, this is probably the safest way to start, just having a dev and a prod. You don't have too much to control. You don't have too many things that can go wrong. It's an easy place to just keep separate in your brain as well. So those are the 3 main environments. Again, within that, you can have probably 100 varieties of different things within it. You could build a different one for each variation, right? You could have the limited access multi-environment, but you could still create a test environment where people can come in and look at it. So play around with it, see what works best for you. I'd love to have a chat with anyone who's got it figured out and they're like, this just works really well for us. Regions. So I think there was another data breach today. Another company's had another data breach. So regulations and governance about where your data is stored becomes very important. And so within that, when you are training your data, that data is stored somewhere. You might have regulations within your company about where that can be stored. That's a very important consideration to make. So if you are storing, most likely a lot of people here might have requirements that it has to be stored in Australian land. No problem at all, there's data centers available to you. Or if you're working for a global company and you've got data sitting in Europe, then you now need to consider also the fact that the data you're accessing is covered by GDPR, and there's different rules that come into play with that. So when you're training, make sure you know exactly where your data is sitting and the rules that are kind of playing into that. But training has one more aspect to it, which is your compute. You're talking about machine learning. There's machines involved. Where are your machines sitting? That's usually the thing people forget about. Make sure that's also sitting in the same locality. If you want low latency, that's not a big problem for you. Just make sure it fits into the rules and regulations that your company's trying to put in. Serving. So usually the kind of recommendation is to make sure that the model is being put into production and served up to your target audience in their local region. So if you're based out here and you're building all these models, but your target audience is sitting in America, it might make sense to actually deploy that at the end to America itself. Your data can stay here, it's just the model's actually being talking to in America. So all those different aspects can be played into. Again, worth looking at and actually identifying exactly where different aspects are going to be needed. So fine-tuning, especially in the LLM world, right? We start to see a lot more of this, hey, we've got a really big model that knows everything, and then we can just tweak it to know exactly our small little thing, right? Fine-tune it to understand our specific context. The same thing can be done here, so you can have a global model that maybe has been trained in Europe or in America, and then you can actually have a small regional aspect of it based somewhere else. So again, I think regions is one of the main things people kind of actually forget about when they're setting up most of these things. And it's really hard then to actually be able to take that back and move everything over. It just requires a lot of effort to move most of these things from one region to another, especially in a cloud context. So those are the three main kind of setup considerations to keep in mind when you're starting to build this process. But then it comes to the pipelines, because we talked about how we want to make the whole thing automatable and fast and scalable and reliable, right? So fast, reliable, the main key aspect of that is usually it's automated. So there's no humans being pesky and breaking things or not doing things when you ask them to do the things. So we build in pipelines to it, which is the main aspect of MLOps. So those are the four kind of main aspects of our ML process. There's a few different pipelines that go associated pretty well to them. The data pipeline, which does that whole data management aspect of it. An environment pipeline, which actually builds your environment so that you don't get it wrong, or you might have been working on a specific version of it and things get changed and things get updated, and you don't want that to happen because then everything breaks at times. I've seen it happen. So you can have a pipeline that actually just sets up the right level of it before you're ready to upgrade to the next one. The model training pipeline, which just kicks off the job to actually go train a model. And then the deployment pipeline, which will serve it up to your customers wherever they want them to be served. So let's dive through them a little bit. So the data pipeline would have the creation of the data set, putting it into the right data storage, and then actually registering it as kind of the final data store where your model expects it to be. So it'll do all of that in one go. Your environment pipeline will just create that environment, right? Your custom package, whatever your model and training environment needs, all of it is in there, ready to be produced, off it goes. The model training pipeline then uses the previous two things, so the data store created and that environment uses those two to be able to actually create the experiment and train our model, and then it gets pushed out to like, hey, I'm the final model, I swear, I'm the right one. You don't need to name them because it's kind of automated this time. I'm not naming them XYZ final model 25. And then the final one, which is your deployment pipeline, which will be picking up your registered model in the environment you've actually set up and built to be able to service it and deploy. Within all of this, obviously, a lot of monitoring is happening. So this is where the ML engineer is constantly just keeping track of where everything's going on. Is it the pipeline breaking? Is there anything going wrong? And if there is, where is it and what's breaking? And then they come back and be like, hey, the data going from this source problem to this one, it's not working because something's gone wrong and the data is not coming through properly. And this is where that communication aspect comes back into, is the data engineer and the ML engineer really good at talking to each other? Or, hey, the model is just giving us completely bonkers results, which again happens all the time because models can just do whatever they feel like if something changes. Can the data scientist come in at the right time to be able to go and fix it? So the way we usually look at these pipelines separate it out is to be able to kind of deal with those scenarios. When one thing goes wrong, you can kind of dive into a specific pipeline instead of the whole project in and of itself to try and find out what's going wrong. Within that also, so triggers. When should you be triggering them? These are all based on different timelines. You might have data coming in every minute, every hour, every single day. So you probably want the data pipeline running maybe every day, depending on your context, maybe even kind of hourly, to be ingesting the new data and adding it into the data set. But you don't really want to be retraining your model every single hour, every single day. It's going to start charging a lot. It's going to add up in terms of costs, but also, is it really worth it? Like, is your model really going to change that much from 1 hour to the next? You might have a data set that it would, but most use cases at this level, and this is kind of scale of it, probably don't have that. So it might be a weekly retrain that you need, or a monthly retrain. And you can surface that to your business users of, hey, this model is only updated to this date. And that's when the next pipeline will be updated. Rollbacks. When things go wrong, this is kind of the main aspect of MLOps. If the data has changed, and it's changed in a format that's completely breaking the tables and the structures that you've put into place, you can kind of roll back to the previous one. Or if the machine learning models start acting up, like, okay, well, we have the last registered model that we know still works, so we don't have downtime. That's the main kind of aspect of these that we want to keep in mind and consider. So the best part of pipelines is essentially those aspects that comes into play. Just a few extra things, again, to keep considering. I don't know, have I talked about naming conventions yet? Please name your things properly. It goes a long way, not just for you to be able to think again, but find things again, but also when there's new team members coming into play. Handovers are really, really hard to do. And in the day and age of things moving around and like team members moving around, communication's key, so making sure it's actually really easy to understand and having documentation. I don't think I actually wrote documentation, but God, write your documentation, folks. It'll help yourself out within the time, I promise. Like, you don't even have to wait for someone else to come into your team to see the value, you'll see it yourself. Code quality checks, this should be something that's built into your team. So every couple of weeks, every couple of months, you should be going back over and checking how your data or your code base is looking. Is it worth it? Everything correctly woven? Model validation. So this is, again, something we keep monitoring. If this can be actually done probably at the same time as whatever trigger you send to your updating the training pipeline. Making sure it's all working. It's not just randomly breaking in different places. The overall model might look great, but if you're looking at one small aspect of it, like, hey, this model's really good at predicting global Australian revenue, but it's actually terrible at doing it for Perth because there's not enough data. So looking through different aspects of your model and understanding exactly what's going on is very important. And the biggest one, resource utilization. Your cloud footprints are important. They do take up energy and they do take up costs. Even if you aren't looking at them on a daily basis, please remember that part. Because we don't see these machines, right? Like, we've just clicked a few buttons and we've got access to these huge computes. But they are sitting somewhere and they are generating emissions. Be mindful of that, I guess, is my kind of big shout out here. Be responsible with your uses. But also, I'm sure there's somebody sitting up the line looking at your exact costs and being like, why is there an extra $2,000 going on here? Keep it in mind. You don't have to get traced down for those kind of numbers. I guess one kind of, look at the time, I think we're good. Where to do all this kind of stuff. Usually, most businesses will be looking at some kind of cloud environment to be doing this in. I can see Databricks staring at me, Vinny. But no, there's going to be some aspect of wherever your enterprise or business that you're working at is already set up in a cloud environment. Most of the cloud environments are compatible with doing this. If you are based in Azure already, Azure DevOps, all those repos and stuff, everything is basically built in and it all connects up fairly seamlessly. The same thing will go for all other cloud providers as well. I won't spend too much time into where to do this, because then we'll get stuck in the how to do this, and that's a whole different conversation in and of itself. But let's do a quick recap of what we've kind of covered. So what are we looking at is how do we operationalize our machine learning models? The biggest problem is, hey, building a model, dime a dozen at this rate. Like, everyone here can probably go and build a model in the next 20 minutes if you had to. And if you don't think you can, come talk to me. I can promise you can do that. Every single person here can do that. But how do we actually use that to be able to answer problems and bring it out to a business and actually get it usable? That's the biggest problem. So this is trying to help kind of fight it, I guess, and solve the problem. The why, we want to make sure the things that we are building actually get used. We don't want to be sitting in a burning room where we've done all this work and it's gone and no one actually cares. We do want to matter and we care about the work we've done, so we want to show it to people and making sure it's reliable and it's usable at the end of the day. So when should you do this? It's usually a case of, hey, if you've got funding, there's business backing behind you to be like, yep, you can go do this now. It's usually going to be the when. But the other aspect is also when you have a model and you know that this is something you can build, where you've already tested it out. Like, okay, we have a model that can be worked in this. Let's actually put it into production. The where, again, will depend exactly on where your environments are already based. And I'm not going to comment any further on that because I've got my own preferences. But wherever your cloud environments are, usually it's going to be in a cloud environment to help productionize this. And then the how, we kind of briefly just covered kind of the considerations on the how before you do it. Maybe for next time, I will come back and do a talk on how we actually build all these things. Do I want to? Not really, because it is a minefield. But we can have a chat about it if anyone actually does want to talk about that. So I guess that's everything. Thank you for listening to me. I really appreciate it.